Welcome to our review on pressure and volume. First thing we need to know is the relationship between pressure and volume, and we can describe this relationship as inversely proportional. So what we mean by that is that if we double the volume, the pressure will halve, and if we halve the volume, the pressure would double. So when one decreases, the other increases. What we need to think about here though is when we're answering the questions, to go careful on how we phrase our answer, because it's not going to be enough if in the question they've said to explain what happens to the pressure when the volume doubles. If you said it reduces or decreases, you're not going to get the mark for that. So as soon as they're using words like doubles, halves, etc., you've got to use those same terms in your response. So if they were to say that what happens to the pressure if the volume doubles, you would have to say that the pressure would halve. So make sure you are being specific in your answer to not throw away the mark. When we consider what happens as those gas particles collide with the surface, then they produce that force at right angles to the surface. So if we then think about what's going to happen as we change the volume, if we halve the volume, then what we find is that there are twice the number of collisions each second with the sides of the container. And to give you an idea, I've given you a diagram at the bottom showing why that is. In our first volume, the one on the left, we've got a much bigger space for those particles to move around in. Therefore, they're less likely to collide with the surface, which means we will obviously have a lower pressure. Whereas when we reduce the volume, then those same number of particles are moving around in a smaller space, which means they're more likely to collide with the sides. The next thing we need to be able to do is to actually carry out calculations involving pressure and volume. So this equation is one you don't have to learn. So pressure times the volume is a constant. So by a constant we mean something that's not going to change. So to give you an example of a kind of question we could get here, you have a large syringe of air. When the pressure is 2 times 10 to the 5 pascals, the volume of the gas is 4.0 times 10 to the minus 6 meters cubed. Calculate the volume when the pressure is 5 times 10 to the power 5 pascals. So the first thing we do is pick out those important parts in the question. And remember, you're allowed to highlight, underline, circle the key things, just write them in a list, whatever works for you so that you don't have to keep reading the whole bit of text again, do that. So we've got 3 different numbers there which I've highlighted in red. Then we know that the pressure times the volume is a constant. So we've got a pressure and a volume for one of these scenarios. So what we can do is just substitute those in. So we've got 2 times 10 to the 5 times by 4 times 10 to the minus 6. Now when we work that out, we find that the constant is 8.0 times 10 to the minus 1. So we then have a constant because that's going to remain the same, and we've got the pressure for the other scenario, the one we need to work out the volume. So all we then need to do is rearrange the equation at the top, which will be our constant divided by pressure gives us the volume, substitute in the 2 values, and that will give us our answer. Do remember when you're doing calculations to always write down each step of your working, so that even if something goes horribly wrong on your ability to use a calculator, to copy from the screen of the calculator onto your answers, or even just to somehow write the answer clearly enough for someone to understand, at least you can pick up some of the marks for the working, even if you don't get the one for the overall answer. Hopefully at the end of this video you can state the direction of the force of a gas on the surface of a container. You can explain the relationship between pressure and volume for a gas at a constant temperature, and you can apply the equation for pressure and volume.